Let's talk about logarithms. So the DAT topics we're going to talk about in this presentation are formatting of logarithms, properties of logarithms, log base 10, and natural log. So here's the general format of logarithms, otherwise known as logs. Logarithms can definitely look intimidating if you don't know how to understand them, so let's break it down. First, we need to understand how to read this, or how to say it, and then second, how to solve them. So how do you read this? I would say the log base b of x equals c. And b, x, and c are all numbers. An example of this format could be this. Log base 2 of 8 equals 3. Or the log base 8 of 64 equals 2. So that's how you say it. Now, how do we make this more understandable, more solvable? You actually don't need a calculator for these problems. There's actually a pretty simple way to solve it. You scoot the base b, you scoot that number down under c and push c up to be an exponent. And that is equal to x. So here's what I'm saying. X equals b to the c. So I just imagine moving that b right over here, pushing that c up to the exponent. Let's do some examples though so you know what the heck we're talking about. Practice problem number 1. Log base 2 of x equals 3. Let's do this one together and then I'll let you pause for the next one. So first step, we take that 2, scoot it right underneath that 3, and push that 3 up to the exponent. That gives us x equals 2 to the power of 3. And 2 to the power of 3 is 8. 2 and 2 to the power of 3 is 2 times 2 times 2, which is 8. So hopefully you can see how we could solve for x if there was an x here, an x here, or an x here. By just knowing this rule, and the x will just move to wherever the x is in here. So problem 2, let's try a little trickier one with x being in a different spot. Now first of all, let's see if you can say this correctly. You should have got log base 8 of 64 equals x. So we'll be solving for x over here this time. Now pause the video and give it a shot. 3, 2, 1, let's do it. All right. So we're going to do this the same way we would solve any other logarithm, which is take this 8, push it on over to the x, and scoot that x up to the exponent. Now this is the trickiest type of logarithm question that they could ask, and because of that I don't think they will ask it this way, but I'm throwing it in there just so you know what the trickiest version could be. Because once you get to here, 64 equals 8 to the x, if you're so focused on the math, you might freak out and say, oh, I don't know how to solve this any further, I don't know how to simplify this any further. I guess I'll just have to guess and move on. But remember, the DAT is not trying to trick you, and your basic calculator won't have the ability to do logarithms or natural logs to solve this the math way. Therefore, if the test ever asks you to solve this, it's probably easy to just think through. So for example, this one, just take a step back and think 8 to the power of what gives me 64? 8 times 8 is 64, 8 squared. By the way, that's another thing worth memorizing is squaring numbers 1 through 12. You should have all that memorized. If I ask you what's 9 times 9, you should instantly know that's 81. If I ask you what's 11 times 11, you should instantly know that's 121. Those are just things you should know. 1 through 12 squares. So anyways, 8 times 8 is 64, which means x equals 2. There will occasionally be times where the DAT could test you on something like this, where you're stuck and based on your knowledge you don't know how to solve it, and you just need to take a step back and think it through, and that'll still give you the answer. All right, log base 10. Most commonly, logarithms are expressed in base 10. So if you ever see a log without a base written, it is base 10. That is the assumed base unless otherwise specified. So what I'm saying is this. Log of x is an absolutely real thing, and this is log base 10. Now let's quickly talk about natural log. I don't think this will be on the test, but let's talk about it. So if it does appear on the test, you have this little nugget of information. E is an infinitely long number like pi. E is about 2.71, just like pi is about 3.14. Log base e is natural log of x. So if you ever see on your scientific calculator or in math ever, natural log, that is log base e. The only type of question I could even see the DAT really asking on this is it could ask you, what is the base of log of x? You know that it's 10. If a question ever asks you, what is the base of the natural log of x? It's e. I'm not going to waste any more time on it because, like I said, I don't think anything on natural log is going to appear, but just in case, there it is. So let's talk about some properties of logarithms, aka doing operations with logarithms, doing multiplication, division, plus, minus, whatever. So if we have the log base b of n times k, that equals log base b of n plus the log base b of k. So you can split n and k and just add them together. Again, multiplication becomes adding those together. The next one, division. Log base b of n divided by k. The log base b of n minus the log base b of k. So multiplication becomes addition. Division becomes subtraction. Now with exponents, log base b of n to the k equals k times log base b of n. So we just took k out front and then left the rest the same. K times log base b of n. So here's our summary slide on logarithms. If you don't have a lot of experience with logarithms, this one can be a little overwhelming, so take a breath, rewatch it in a day or two. It'll make sense, just keep practicing with it. There's only a few things to really learn here, and then you got logarithms down. So as our review, the log base b of x equals c is the standard format, and the way that we solve that is by taking the b, pushing it up underneath the c, making that c the exponent, to give us x equals b to the power of c. Next one were the three properties that we talked about with logarithms. Log base b of n times k equals log base b of n plus the log base b of k. Log base b of n divided by k equals log base b of n minus log base b of k. And finally, log base b of n to the power of k equals k times log base b of n. All right, good job getting through that one, guys. I'll see you in the next one.